Okay, yeah. So we're gonna learn a little bit about programming vectors, and programming vectors in SVG format is it's the most rudimentary kind of way in which you can make them. So usually SVG format is, well, I shouldn't say usually, but uh, at least for me, the way I'm used to looking at SVGs as like an illustrator, for example, is, or as an artist or a person that does visual things, isn't something like this, right? Oh, hang on. Came in. Okay. Isn't something like this. This is Adobe Illustrator. It's a really good program. I love it so much. Like that Photopea program that we used is a great alternative to Photoshop. I am just like over the moon that it exists. I have not found a good alternative to Illustrator. The best thing out there is called Inkscape. That's like a free-ish, yeah, it's free, open source. Here it is. You can find it at inkscape.org, and it's quite good, but the interface like is it's a little clunky, and just like the shortcuts are unintuitive, and it's a little hard to like move from this professional software that is Illustrator to Inkscape, which is like clearly just not at the same level. However, it's the best thing out there, and it's really not that bad at all. So I highly recommend downloading it and using it if you want to make SVGs visually. And then this is our old Illustrator, which like is so beloved by so many people, but one of the issues with it is the same, like I said, for all Adobe products, is that you have to now pay like $10 per program per month, and that just can escalate quickly and turn into a problem. So there's a steep learning curve and kind of like a high cost of entry. So we have these things to balance out. But so that's the visual creation of SVGs, and then we can also code them from scratch. So that's what we are going to do today. We're going to start programming them, but I will show you just a little bit about how we can make them visually, just so you like have an idea, have a reference. And maybe you already know Illustrator, in which case I apologize for this quick tutorial, but I'll just show how to make a circle of stars. So Illustrator has some presets, and it's kind of small on my screen here, but I clicked on this rectangle in the toolbar, and there's a choice of making a rectangle, an ellipse, a polygon, a star. For some reason, I guess people love stars, so we'll pick the star. So this is a shape preset that it'll just automatically draw for you.
I don't
And
think your screen is shared.
oh, my screen isn't
Yeah.
shared. Oh my, thank you for telling me. Sharing screen. All right, so this is the website for Inkscape, inkscape.org. It is, yeah, like I said, I kind of bashed it a little just because I love Illustrator so much, but it's really like as close as you can get to excellent. Um, so I highly recommend downloading it and using it. But yeah, I'll just show you a little demo. So here's the toolbar. It has this shape tool on it. When I click on it, it gives me a pop-up menu of like presets basically. So at its most basic, if you're drawing vectors, like with a drawing tool, you would just like make a bunch of points and connect them, right? But then we can also have this like little preset where the program already drew the points and connected them to each other for you. So you have a perfect star, and you don't need to like worry about making the star and like calculating everything, which is what we're going to do shortly. So we have a star here, and like let's say I want to make a beautiful design. So I might like to duplicate the star in Illustrator. You can hold down Option and drag and Shift at the same time, and you can get like a copy of the image right below aligned with the original image. And so now, if I want to make a composition out of them, like a programmatic almost kind of shape, I can double click on my rotate tool over here, and I can just tell it programmatically, like, I want you to rotate 30 degrees angle, and I want you to make a copy when you do that. And so it rotated my two stars 30 degrees and copied them. So it's doing all this math for me, like through my visual interface. And then if I hit Command D, I can like duplicate these stars and the rotation as well. So I can duplicate all the operations that I just did. And lo and behold, I have this like cool circle of stars. And it's just like done, and it's perfect. And we can observe some interesting properties, like the fact that the star is not symmetrical makes the circle be closed on this side, but like kind of open on this side. It's interesting. So maybe I'll like rotate it so that the open side is up. Cool, that's like almost a logo, right? I could put my name in there or something. All right, so I made this pretty quickly and easily. It's pretty neat, and I can save. I don't know if we save as SVG or if we have to export. Yeah, we can save as an SVG. So if I go to my export menu here, I get this SVG option on my save menu rather, and I can give it a name. So I'm going to name it _star because I have utterly cluttered my desktop since our last meeting, and if I name it star, I'm going to have to scroll down forever. So the underscore automatically makes it rise to the top. The underscore is like before A in the alphabet. And you can see on my desktop up here that I already have resorted to this technique several times. Disaster. Okay. Saved it. So it has a font types that it pulls from. I guess I'll pick the SVG one and I'll say okay. Cool. So that's my image. I saved it. I can quit Illustrator. It was very nice. And now what I can do is I can go to Atom and I can hit Command O, go to the desktop, and I can pick my star. And this is this is terrifying, right? This is the information inside the SVG. But if we kind of start inspecting it, it says XML version 1. So that sounds familiar to anyone?
It's like HTML?
Exactly. It's just like HTML. So this is a markup language as well. It has the same, like you can see it's color coded the same. It even says here doc type SVG public W3C, so something from W3C. And it's an English SVG. I wonder what an SVG in another language looks like. So this is it's a markup language, and it's a method of storing images. Maybe I shouldn't have closed that. We can use the preview. So when we look at it like this, it's an image, but when we look at it in Atom, it's code. So it's a method of storing images that's markup based. And here we have kind of similar things that we're used to from dealing with HTML. We have like an ID. So that means already we know that we can give it attributes. We can like move it up and down or like stretch it out and change its color and stuff like that. This, I don't know what it means. We could look it up, but it looks like XML-NS. Maybe it's like the version of XML. I'm not sure. Xlink. And then it has X and Y, so like where it's drawing the SVG. And then here we have our shapes. So our star is like just defined as a polygon in SVG. And then we have a fill, so you recognize these colors. Hexadecimal color. We have a stroke. The stroke is black. So if I change this to FFFFF, you'll see that the stroke is going to be white. And I think that even in our preview on Mac, you should see the difference. Yeah, so you can see these stars over here have a white stroke. They don't have this outline that these have. Miter limit, that's like when the stroke bends, there's like a sharper or like more dull point. And then we have the actual X and Y locations of the points. So 308 pixels, I guess not pixels because we're in abstract space, so it's a decimal. And then by 305.449, and then we like go to the next, there's a space, and then we go to the Y value of where the pixel is. No, wait, X, Y, X, Y, yeah, so there should be 5 pixel points per polygon. This is a little more complex than the ones that than I would make by hand. But yeah, this is the inner code of our SVG right here. Pretty cool. Okay, so if we have this, then what would it be like if we made our own? So I have started making one here, but I'll start a fresh one. And since we work in HTML, we can do our usual like HTML and then close HTML. I highly recommend that you follow along. Let me just put this in the correct place. SVG demo right away. And I'll call this color wheel because I would like to make a color wheel. .html. Okay, cool. So we're going to give it a head tag. Even though we're probably not going to put anything in it. And a body tag. And we want to indent them somewhat. And then in here, I'm pretty sure we can just say SVG, close SVG. I'm going to refer myself to the star. Yeah. And then we have inside these polygons. Okay, cool. So what I want to do is actually, yeah, I also want to make a polygon out of points, but I want to make a square. So let's say polygon, and then I don't know if they closed the polygon tag over here. Let's check. No, it looks like it's self-closing. So you see this little dash at the end of the tag. So it's a self-closing tag, just like the image tag is, and the break tag is. So it's polygon like this. Okay, cool. And then it has its attribute of points. So I'm going to copy that from here too. Okay, I know that I want to make my point have a stroke that's dark, just so that we can see what we're drawing when we start drawing. And I also want to have a thick, like make sure the border is pretty thick so that we can see it, although I don't see any indication of like stroke weight over here. So maybe that'll be fine for us. We shall see. And then we can code the points. Points with an S. Awesome. Okay, and I want to make a square, and then we're going to have a fill, right? This is the part I'm most interested in, so I'm going to look it up right now. Okay, they put the fill at the beginning. We can probably put the fill at the end as well, but it's probably easier to see at the beginning. Okay, and what I would like to make is color wheel. We could go to the hex color wheel from W3 schools to get our values. Okay, this is kind of perfect. I want to make this basically, so let's just take their values. So this is their initializing red, beginning red, FF0000, which translates to full RGB, 0 green, and 0 blue. Yes, okay, and now we have to draw our polygons. So I just want to draw this basically. So I'm guessing the first point will be at 0, 0. Then the next point, we can just invent something. So if we start at like a base of 0, 0, like we're on your standard graph, the next we're going to move down the x-axis, but the y is going to stay the same. And so this could be potentially like 100 and then 0 for the y. I hope this works. We will find out. And then let's see, we can go up a little bit. So we can say stay at 100, but go up by 20. And then we want to go back to our initial line. So we're going to say, and then you're back, the x is back at 0, but stay 20 units up so that we have a rectangle, right? So we're like drawing a rectangle on a grid. And now the moment of truth. Yay! A polygon has appeared. Okay, fantastic. So that's our polygonal rectangle. And now let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, oh, holy moly, 11, 12, 13, 14, 15, 16, 17. There's like 26 of these. That's too many. Let's do, should do 13 every other one. Even that kind of sounds like a lot, but okay, so we could just copy and paste for now. Maybe we do 7 like your standard rainbow. All right, so this is great. And let's take the color. So the next color would be this one, I guess. Confusing, because this is not like a standard rainbow. It doesn't really end at purple, and then there's this magenta thing over here. So bear with me here. Okay, so I'm just going to take every other one and hope and see where that goes. So that's the yellow one, green. Okay, we got up to cyan this way. Okay, and I think I don't want to take that last red because it looks like, yeah, it's the same as our initial red. So we don't need that. And we can line up all of our information so it's like good and organized. Save and drag into Firefox. And they all drew themselves on top of each other. So we drew this one, and then we drew this one, and then we drew this one, and because the last one is this magenta one, they all have themselves in the same spot. I'm muting my phone. Okay. So now we're gonna have to deal with this. So one way that we can, it's kind of interesting if you look at the way that the F's flow through the hex, like it kind of makes a diagonal line. It's kind of neat. And the zeros, so it's like a visualization of the color even in the text. Cool. So one way that we can do this is we can offset all of our points themselves. Or another way that we can do this is similar to when we were in Illustrator, we can move the entire shape over. So I rather move the entire shape over so that I can just fiddle with the amount of space that I've moved the shape rather than fiddle with the amount with every single shape in particular, if that makes sense. And so we're going to use the translate function. Let's see if it shows up here. Maybe it doesn't. Oh, yes, I think it might be here. No, so they just drew the ellipses in different locations. But I really want to do translate. It's transform. Okay, transform equals translate.
Yeah.
Okay, and then this is formatted a little differently. So I'm just going to copy this part and we'll see if I put it in the correct place. So if I have this polygon, I'm going to say transform. And I want to translate it. So I want to just move. So rotating is going to rotate. Skew is like this like stretching distortion option. Scale is a sizing. And translate is moving. So that's what we want. Okay, and this says translate negative 36, so we're moving 36 points this way, not what I want. And then positive 45, so on the y-axis it would go up or down, up, I think. But I just want it to go forward, and I want it to go forward by 100, because that's where everything, that's the size of our shape, and I don't want it to move on the y-axis at all. Oh, interesting, it's not comma separated. Okay, so we have translate 100, 100. So this is, 100, 0. So this is like, we're manually inputting all the information in this SVG. And when we get to using JavaScript and when we get to using JavaScript, you'll see that you can start to use formulas, like mathematical formulas, like we saw in the festival. All of the artists use like oscillators and different kinds of math, algebraic math, to move their vectors around. SVG is like the most basic level of that, so you basically just have to like by hand enter all these things if you're using SVG directly. But it's interesting to look at just so you know how it works, and so that you can later on, once you get to using JavaScript, you can apply different effects to these points that are in the SVG. And for that, it's useful to know what they're doing and where they are. Okay, so let's see how this translate is going to work out for us. Yay, so we moved our orange forward. So now we want to do this everywhere. And I believe we're going to have to, because it's all in one shape, we're going to have to change these up. Am I dreaming? Polygon transform? I don't even know. Also, like, this is orange too, which is super confusing to me. Okay, these are the same color. So for starters, let's get rid of this line. That's the green one. That's this one. Okay, let's see what happens when I move it like, oh, you know what? I might not have, so SVGs have this quality, which is the width and the size of the SVG is kind of like, it's called a viewport. And it's like this border around the SVG that you're dealing with that defines like the size of your canvas, basically. So you can't draw the SVG as big or as small as you want to in your HTML code, but it has to be like, you have to define the canvas that you're drawing your SVG on. And I did not do that here, so maybe that's why. Let's find out. So here there's this view box that I never set for my SVG. So I'm gonna say I want it to, I'm guessing these are the starting points, maybe. We'll find out. I want it to be 1,000 pixels wide. I want it to be 12,000, no, I want it to be 12,000 pixels wide and like 100 pixels tall. Let's see if this does it. Yes, it worked. Okay, so we have to define our viewport before we define everything else. And it looks like that yellow I deleted. Maybe I should not have done that. So let's put it back. Because it feels like we're missing a color here now, right? Right there. Okay, 1, 2, 3, 4, 5. Save. Whoa. It's because of 2 hashtags. Okay. That's not in the right place, but we're getting there. So these 2 before it are very, very green. Okay, so now we've made our line of colors, our line of web-safe colors. It's showing us the entire thing. And we've moved our individual polygon clusters via a transformation process. So we're not like re-entering all the points. So we're abstracting a little bit what we're doing in order to create the shapes and plot their locations. So that's helpful. And oops. And we're going to use this now as a basis to make further transformations to our next